Hi, students. I wanted to make sure that you did not forget any of the wonderful physics we've studied over break. So these are going to be some review questions and some new questions about momentum impulse theorem, and the conservation of momentum, which we covered on the very last day of class before break. So question number 1, explain 2 ways a heavy truck and a person on a skateboard can have the same momentum. Well, one way this can happen is if the truck goes very slow and the person goes at regular speed. That's one way. Another way is that the truck goes at regular speed and the person goes very fast. So here's the underlying idea. We know that momentum is mass times velocity. So let's say we have a truck that's 2,000 kilograms, and let's have it go at a millimeter a second, literally 0.001 meters per second, and then its momentum would be 2 Newton seconds. Now, let's take a 50 kilogram person, and for them to go at whatever speed they need to, let me say it this way. If we have a 50 kilogram person, and we want them to also have 2 Newton seconds worth of momentum, then their speed would need to be 0.04 meters per second. So in other words, they would be moving at about 4 centimeters a second. So significantly faster. A very slow pace would definitely give them both the same momentum. So the big picture is you just basically play with the numbers to make the momentums match. Now, in stopping an object, how does time of impact affect the magnitude of the force used to stop the object? So when you have these concept questions, what you want to do is this. Force and time. Let's write down the impulse formula. Now let's think about the egg drop experiment. So a small time leads to a big impact force. And then a big time is going to actually lead us to a small impact force. So that's really how it works, because if you increase one, you can decrease the other and keep the impulse the same, which is what we discovered in the egg drop lab that we did. Now, what is the relationship between impulse and an object and the change in momentum? Simply, the impulse causes that change, the change in momentum, and the way we write that is the formula: the impulse equals the change in momentum. For a constant force, the time applied to an object doubles, the impulse will double. Here's how we know. F times t, right? Versus F times double the time. And that'll give you 2ft. You've literally doubled the algebraic quantity. The change in momentum, since impulse equals the change in momentum, we can actually take this idea and say that it is doubled because F times T equals mv minus mu. So if we double the impulse, we double the change in momentum. So that is page 1 of the winter break homework.